Okay. Good evening, everyone. How are you doing today? Good evening, online. Online, good evening. Okay. So, hope everyone are doing good. Yeah. Yes. How is your health? So, my health is okay. Much better than you can see. Voice is better than yesterday. Little bit voice is coming up. Yeah. Thank you for all your wishes. Okay. So, what did we discuss in our last class? Uh, yeah. Huh? Tains. We tains. Next. Variables, tains, file structures we have learned, right? So we have done couple of, we created S3 buckets. We created launch EC2 instance with the file structure. And also we discuss about what? Tains. And we discuss about the workspaces. So did you guys complete it? Hmm. In progress. How about you? Anna, Subhasha. How about you online? Yeah, sure. Finish. Did you guys complete it online? Practicals? Fully VP is also done, na? Very good. Hmm. That's how slowly we need to what expand your things. Very good. Okay, so today let's move on to the next topics. So before that, I just wanted to ask. I have one thing to say, everyone online. So you know, right? We are coming to the close to end of the course, and we have few more days on Terraform, right? After completing the Terraform, we'll be doing few projects, right? So that projects, your previous batch and your batch are both are in the same. So only 1 day difference. So 5:30 and your batch only 1 day difference classes are going. So and the projects that we'll be doing it. So we'll be doing EKS clusters and all, which will take a lot of time to create, lot of time to destroy it also. At least 15-20 minutes it will take to create and destroy. So what I'm planning is to merge you guys only for the projects. The last days, right? So you people 7:30, you might need to come at 5:30, and then because in that too the project will not be completed in 1 hour, so it will be extended. So if I extend the previous batch for you, it will be half an hour delay, and if I extend your batch, so instead they'll close at 9 o'clock, so it will be delayed there. So for that reason, so if it is okay for all of you, after this Terraform, so for the projects, I'm planning to merge you. That meaning you might need to come at 5:30. Is that fine? Offline? How about you? Online, please. Offline, agreed. Yeah, good. Online, please. That will be only for 4 days or few days only, 4-5 days maximum. Timings 5:30. 5:30 to you can take 2 hours. If the project is done for the day, we are done with it. Otherwise, if the project is, it's depend upon. But the thing is here, the same process will be in DevOps pipeline. We already did it. No, DevOps pipelines we have done many times. Same pipelines will be repeating it. The source code will be different. But this time we'll be setting up through Terraforms, through EKS. All those things we'll be doing it a little bit. Nana, everyone online, please. Is that okay for you? Please put okay. Yeah, correct. Dinesh. Very good. Yeah, great. So thank you. I'll let you know when it is. And from Monday, your classes will be started normal time, um, 7:30 from Monday onwards. Because you know, right, new batch is getting started at 4 o'clock in the evening. So that batch will be from 4 to 5:30, and I have 5:30 to 7:15, and for you will be 7:30 to 9. So, from Monday your classes will be on 7:30. Okay, and when will we merge for the projects? I'll let you know when. Okay. Yeah, new batch, AWS DevOps. So those who are asking for new batch, so 4 p.m. from Monday it will start 4 p.m. So if you have any people or friends waiting for it, just inform them once. Super. Okay, so let's move on. Tomorrow class will be there. Tomorrow class will be there. So your timings are, what is your usual timing in the morning? 10:30. Yeah, tomorrow 10:30 a.m. Yeah. Okay, so let's move on to today's topic. So in our yesterday's class, what we did, we have learned about the local variables or not? Locals. We had learned about the locals, right? And then we worked on the workspaces. And the next topic here, what we'll be learning is, there are a few other examples also, you can do it. Dynamic local variable, what is that? Dynamic local variable only, but we are not passing the values directly, but we are passing it dynamically. So this one I got it little bit fun, so I'll just take it. Um, guys, the machine is already set up. Okay, so let's go with the provider first. Provider AWS region is equal to AP minus south minus 1. Okay, see here. So this is a small piece of code that I have. This is related to your, can you please go through this and tell me what it's doing? And then hold on. So, okay, can write the output if required. So meanwhile, I'll write something. So you try to analyze the code. Tell me the outputs. Okay, tell me output. How many output blocks are there? 2. What is the first output block will print? What is our default workspace? Default. Okay. What is the second one it will print? Instance type. Which instance type? Will it print M4 larger, T2 small? Hmm. Here is the logic, this part. We are in the default workspace only. We are in the default workspace only. So based on that, tell me, which one will print? M4 or T2? Okay, should I explain? Okay, see. So this is a resource type and this is the label, dynamic local variable instance. AMI is fine. Instance type, what's that? Instance type is equal to, so the value that I'm passing for the instance type is first Terraform dot workspace. What is the Terraform dot workspace? Yeah. So if it is equal to what? Prod. Terraform dot workspace is equal to prod. Is it prod for us? If it is prod, it will print this. If not, it will print this. Yeah. So we are passing the variable dynamically here. So here, okay. So let us go ahead and then do Terraform plan. So what is the workspace here? Default. And what's the instance type that it got selected here? T2 small. Now you all understood here. So here instance type is equal to Terraform dot workspace, which is our workspace here? Default. As this Terraform dot workspace is equal to prod, if it is equal to prod, but is it equal to prod for us? No. So the value here Terraform dot workspace is default. So default is not equal to prod. If it is prod, it will use this as the instance type. If it is not prod, then it will use the T2 small for the instance type, and rest are all normal thing. Is this clear? This is called dynamic local. So if you want to pass dynamically the variables here for the instance type, you can pass it like this. What is this concept called, everyone? Dynamic local variables. Okay. So now there are two types of states we learned before. Local state and then remote state. Local state and what? Remote state. Local state meaning what? What I'm talking about here. Whenever I'm talking about state, what is that file that I'm talking about? State file. Which one? State file. So we already have a state file here, which is locally or not. So if I do ls, I have this terraform.tf state. I have the state file, which is locally available. So just in case if something goes wrong with terraform.tf state, so my entire infrastructure is gone or not? Yes or no? So we need to have a backup for it. If we have a backup, then that backup is also still on the same machine. What happens if something goes wrong with this machine? So is it good to keep our this TF state file in the local machine? Answer is no. So if you're keeping it in local, that is called local state. So better where do you keep it? In S3. Where am I in? S3. So remember we discussed this in our starting days of Terraform. We call it as backend.tf. Which one is that? Backend. So can we configure our backend to S3 or not? Yes, we can configure. So how do you configure? We can write the code for that. So for that, first we need to create an S3 bucket or not? Let's go and create a S3 bucket. So let's go to S3. So let's create a bucket. So my bucket name I'm writing here is Terraform hyphen state file hyphen Riaz. Okay, you can give any name is fine. So I'm creating a public or private. Go with all the time private. You have your state file, no? It's always good to go with what? Private. So do you have anything inside it? No. So if I configure my Terraform here, compare launching from the console code is very simple, sir. Yes. Once you start liking this code, Terraform code, you'll be all the time you'll be using Terraform only. You'll be liking it a lot. The only thing is you should know the logics. Good one. Okay, so let us go and write the code main.tf. Okay, I remove the code. So we need to write the backend code. What we need to write? Backend code. So for that, a predefined code is available. So we can use that here. So Terraform block, say that here. And inside this, what we are writing here? Backend. What is our backend here? S3. What is our backend here? S3. And inside this, so we need to write the arguments. So what is the argument here? First, we need to mention what? Bucket name. So what is the bucket name I created here? Terraform hyphen state file hyphen what? Riaz. So inside that, can I provide a key also? Key also? Key meaning here what? So inside that, can I create a subdirectory called prod? If it is prod, prod. If it is dev, whichever it is, you can go with here prod slash, what is our state file name? Terraform dot tf state. So in which region you want to create this bucket? I mean, which region you are telling that to use it here? Episode 1. You understand the backend code? Guys online, see this code once. Backend code. Yes, it's correct, Dinesh. What? Yeah. You can use the direct. So yeah, because of workspace also you can create separate directories here because you have different TF state files, right? Different environments. Is this clear? Backend is clear? Online is clear, please? Okay, let's go and write our resource to launch our EC2 instance. Tell me. Tell me resource block. Resource. AWS underscore instance. And here I call it as label. I call it as my first instance. What is that? First instance. Tell me. AMI. So I need to give the AMI ID. Let's take an AMI ID here. Next, instance underscore type. What is our instance type here? T2 micro. Next, we'll go with the tags. So tags. What is there here? Name is equal to, I call it as any name. I call it as backend. Which one? Example 1. We can give any name. Okay, so this is a resource. So, and I'll create one more resource. Okay, and I call this as my second instance. And here backend example 2. You understand the code here? Online. Okay, So now I am asking you, please write a output block to print the instance ID and instance names. That is a thing for you now. Output. So I want you to print the instance underscore IDs. What I need to put here? Yeah, value. So here I want to print instance here. Very good. We can write multiple ways, right? So you can write a list here. So, okay, tell me AWS underscore instance dot my first instance dot ID. This is one, and another one is dot my second instance dot what ID. Good, simple. Don't make it complex. So now I want to output names, instance names. Tell me values. AWS underscore instance. My first instance dot name is in which block? Tags, right? So you need to use what here? Tags dot what? Name. Very good. Comma. And next instance dot my second instance dot tags dot name. Clear, guys? Multiple ways of doing printing it. So if I run this, what will happen? Yes, error will come. So the rest of the code, you know that automatically. The change that we have done is what here? Backend. But I've been using this multiple times. So now if I do Terraform plan, for example, it gives the error. Somewhere mistake I have done here. Value, which place is that? Okay. Yeah, main.tf. Okay. Here. Good. So if you get an error, you're able to resolve it. Nice. Okay. Now I do Terraform plan. Okay, I'll clear it. There is one error here. Please see and tell me. What do you need to do? Because I've been using this for previous batch already with the local state. Now you have modified to what? Remote state. So for that, what we need to again, we need to do Terraform init. See, successfully configured the backend S3. So now my Terraform file is where? In my S3 or not? So if I run anything here, Terraform approve, apply. So my state file will be created in where? In S3. Should we go and do it here? Terraform, which one? Apply -- auto -- approve. How many machines will be launched here? 2 machines will be launched. Backend example 1 and backend example 2. Okay, so if I see I should be having in S3 bucket. If I refresh it, do you see prod got created here? And inside it, do you see the Terraform state file? And it's always recommended to go and enable the versioning for it. Because just in case if something goes wrong for this TF state, so you have the backups there. So 100% it's better always to go and enable the versioning. So you understand, everyone? So from local state, how we have moved to the, so local state was there previously, right? So if you put the S3 block as a backend, so automatically you need to do a Terraform init you need to do, so that it will see that, okay, your backend is configured as S3, so your state file will be created in the remote state. Got it? Online, is this clear, Nana? So where is my TF files now? I mean, TF state in S3. Yes or no? Do we have anything here? Do you have anything here in local? Do you have anything in local? I did cat terraform.tf state. It says completely null, nothing. So, but here, generally you don't do this in real time, but I'm asking you to do something. Now, I want to bring back my state file from S3 to local. I want to bring back state file from S3 to local. What I need to do? Tell me. How to bring back from S3 to local? Simple as that. Remove the backend code, no, in main.tf. Yes or no? Very straightforward. You're thinking about the command, huh? A pull state file something. Huh? Okay. Okay, no. So, see, huh? Right? So we don't have that much, nothing there, right? So yeah. But remember, you should have versioning there. Otherwise, I told you that's the reason why don't do this in real time. So in real time, your seniors might have configured the backend to S3, and then you junior go there and then bring back the S3 to local, and then they will send you to outside. Okay. Simply what you need to do, you just remove this backend code. Okay. Now, Terraform has any backend code? So when Terraform doesn't have any backend code, that means Terraform obviously look for local or remote? Local. So local doesn't have anything. Does the local has any data in the state file? No. So there will definitely a mismatch or not. So for that, what you need to do is you need to bring that remote Terraform state file to local. So for that, what we need to do is here, see Terraform init, say that, hyphen migrate state, say that. Say that again. Online. Okay. So Terraform init migrate state. Do you see this here? Initializing the backend, Terraform has detected. See, Terraform has detected that you are unconfiguring your previously set S3 backend. Do you want to copy existing state to the new backend? Do you want to copy the existing state? That means already two EC2 instances are there, right? So in our remote S3 Terraform state file, you have the data there. It is asking, Babu, you want to bring the same state here locally? If you say yes, it will bring. If you say no, it will not bring. If you say no, that means Terraform doesn't contain anything here. You got it? Online, you got it now? Online, you got the concept? So if you say yes, so what will happen? Whatever there is there in the S3, that same state file, you will get it here local. So I'm just saying, for example, let's say yes. Okay. So if I do, what's the command to see all the resources? Terraform state list. Do you see the two machines are there? So that means the same state file, we got it locally or not? Understood? So how to configure to the backend S3 and how to get it locally? This will disconnect from S3 connection also. Yes. So once you bring it back, then it's gone. It's done. Right? So again, what you do? Terraform. What you can do? Destroy hyphen hyphen auto hyphen Approve. So again, if I desktop my Terraform state file, will be clean or not? You all understood online? No. It cannot maintain. How come Sonali it will maintain parallelly both in remote and local? No. It should be only in one place. Unnecessary, I'll terminate it. But okay, so I want to run it again. So the next concept here is, but is it clear what I did? So what are the two topics that we have learned now? Number one, dynamic local variables, and second one is, yeah, setting up a config in the backend and bringing the backend to local. Is that clear? So now let us go and apply it again. So I want to show you one thing. Instead of destroy, let's go and apply. So how many resources are there now? Two resources. So we have a topic called untracking a Terraform resource. What's that? Say that again. Untracking a Terraform resource. So can you tell me here, what do you mean by untracking a Terraform resource? Think from your side and tell me. Untracking meaning. So now, how many resources are getting tracked? Two resources, no? How many resources are getting tracked here? Two resources. Now in these two resources, I don't want one resource. Okay, let's say Terraform state list. So these are the two resources that I have it, and I don't want to track one of the resource here. Basically, you are saying to Terraform, this resource, you don't track it, untrack it. State file. If you terminate, if you do anything, state file. Basically, you are removing from the state file in the backend. Either you can go inside the state file and then delete some particular things, but is it good to go and edit the state file? No. So, but what we can do, we can remove it from here also using the command. So there is a command called, say with me, Terraform state rm. What is that? Terraform state rm. Which one you want me to do? AWS instance dot which one? My second instance. So if I remove this, what will happen? This will get untracked or not? Let's see. Removed? Yes or no? So if I do Terraform state list, what should I get? Only thing. So if I do whatever to my second instance, Terraform doesn't care about it. Terraform doesn't care about it. Is it clear? So how to untrack it? So there might be a scenarios in the real time that you need to untrack particular resource where you don't want to track it. Yes, Dinesh, in the state file, also, what is the command? Terraform state list. In the state file, whatever the resources that you have, it will be listing only that. So that meaning in the TF state also, this my second instance will get removed. What will happen? It will check the state list. And what will happen? If I do apply, it doesn't matter to the Terraform. In the second instance, it doesn't even check it. Because in Terraform, in the state file, there is no entry for it, right? So let's do one thing. What we do? What we do here? Let's do Terraform plan first. Let's do Terraform plan. Second instance will not be deleted. Instance will be there, but it is not tracked by Terraform. So Malika, do you see this here? So two machines are there here still. Yeah. And do you see this here? It doesn't care about this, right? Let's do one. Okay. So Terraform, whatever is, let's do apply. Okay. What is doing? It's creating a second, because why? It doesn't have the track of in the state file, but in the Terraform code, we have the resource block of second instance. But if you remove it, will you do the apply in real time? Will be apply, but they will, so you need to be careful, right? That is what the Terraform is, right? So generally, you should not, generally in real time, we will not be removing any resource from the Terraform code. Like just in case if you want to remove, you have to be careful with the logics of it. Okay. So, okay. So if I refresh it, so what it says, it created one more machine or not? See what it created two machines. So one machine is completely not tracked and the second machine will be tracked. So in real time, if you are sure that if you want to remove any resource from the state file, remove it. And if you are sure, remove the code also from your Terraform. These are all bullshit things. You should not do like this. Yes or no? Online, you got it, Nana? Sumalika and everyone. So see, what we have done here is we have removed the resource from the state file. Which one we have removed? Second instance we have removed. Right? And then the Terraform from the state file only we have removed. But the EC2 instance got terminated. No, EC2 instance is there, but we are telling Terraform, you don't know what is second mention. You don't know what is the second instances. And then if you have removed the resources from the state file, it is the best practice to go and remove the code also in your main.tf. Understood? But if you have not removed the code from the main.tf and you apply it again, Terraform what will do? Whatever the code that you have written, that will go and apply again. So again, the code is there, resource block code is there, it will go and launch the second machine. So the previous one is already on track, right? And the second one, it has created the new one. And the second one is getting tracked now or not? So in real time, if you remove the state file, if you remove it, any resource from the state file, make sure that you remove the code also from the main.tf. Online, is this clear, Nana? Got it? Dinesh, Sumalika, other people? Yeah, nice. Okay, so let's say, for example, Terraform state list. How many it will list? 3 or 2? Quickly. 3 or 2? Obviously, 2. Okay, now what we do is, let's remove my first instance. Tell me the command to remove it. Terraform state, remove the second one, because it is easy for, because we need to terminate manually, right? Terraform will not destroy that. Okay, which one will remove here? Second. Which one here? Second. That meaning AWS underscore instance dot which one? My second instance. Okay, now removed. So if I do Terraform state list, how many I'll get? Only one. I removed unnecessarily. I want to get it back. I want to track it back. You understand? What we can do is we can import it. What we can do? Say that again. Import. Say that again online. Import it. So if you want to import it back, you can easily import it. Right? So Terraform, say that command. Import. Which one you want to import? My second instance. And then here you need to give the ID. Okay, let's say if you do this, it will not work because we need to provide what here? Instance ID we need to provide. Which one? Instance ID. So now do you see this? So whichever the resource that you want to import, you can go and import it. Let's say now you have two machines, right? Which one? First or second, we don't know, right? So that's the reason why you should not be doing like this in real time, right? So, okay, let's take this. Okay, nice. It imported or not? So if I do Terraform state list, so I have my two machines. Understood? Very, very, very important command. So in real time, what happens is, see, uh, you have joined one company. You have joined one company, and then that is not, they are not using the Terraform at all. They are not using the Terraform. They're not using Terraform. And then you join as a DevOps engineer, Terraform expert. And then what do you need to do? Tell me. They already having the infrastructure running. What do you need to do now? What do you need to do? Import it. What do you need to do? Import. So you need to import the entire infrastructure. But unfortunately, Terraform, let's say they are optimized. Will you import 50 times? That is a problem with Terraform. Terraform import will go with only for the single resources. For that, if you want to bulkily import the resources, there is a separate tool called Terraformer. Say that. Terraformer. What's that? So when time permits, I'll show you Terraformer also if required. So you need to install the Terraformer and then simply one command. Terraformer import EC2, VPC, RDS. Just give the service name. Whatever is there inside it, everything will get imported. Your Terraform state file will be ready. Understood? So in Terraform, so using you can import single resources, but if you want to bulkly import, so which concept you should use? Terraformer. Online say that, Nana? Terraformer. What? Code. Yeah, possible. There should be some tool for that. And yeah, in AWS also we have something called preview code. Some newly came, right? That is for cloud formation. So there will be, yes, they should be there. Okay. So what is the tool name that we will be using here? Terraformer. What is that? Terraformer. Okay. So guys, is this clear till here, everyone, please? If required, I'll show you Terraformer also how it works. Let me do that. Okay. So now we have the state file where now it is presently where it is in local. So you know how to configure that in the remote. Yes or no? You can configure. So there is also, yeah, second one also imports. Which one you want me to import? Acha. Okay, if I do this, what will happen? Obviously it will. Tell me what will happen. Follow, what will happen? It will import, it will give error. What's the logic, Karthik? Does the Terraform know that machine? The Terraform doesn't know, doesn't have the track. It's completely normal, another resource. Can't we import it? Right? So, did I give the first F9? So, hmm. So if it is already managed by Terraform, it will not import. If it is something new resource, obviously we can import it for sure. Okay. Dinesh, okay. Okay. So if I do Terraform destroy now, okay, I would have done Terraform state list. It might show how many. Okay, let's see how many it will destroy. How many it will destroy now? Yeah. Yeah. Okay. So that is all about import and the concept. Let's move to the next important thing here. Yeah, correct, Dinesh. So we have been using this now. We have created the backend to S3. We have set up the state file we configured to S3. But there is a concept called securing this state file. What's that? Securing this state file. There might be a chances that you have a state file and parallel multiple people might be using that state file and there is a chance to get corrupted. Yes or no? It is not only me that I'll be working in the Terraform with the state file. It might be you or multiple people. They might be using the same state file. So can't use the same my S3 bucket as a backend code? Yes or no? They'll use the same state file also. They will be doing stuff, right? And you and me, they both are doing it. So let's say for you and me, we both are running the Terraform apply at the same time, same state file. There is a chance of corruption or not? So for that reason, what we can do is we can lock the state file. What we can do, we can lock. So how do you lock? In the real time, we use which one? DynamoDB. Which one? Remember DynamoDB? So we can create a small table in DynamoDB and then we can tell our Terraform to lock that Terraform state file in our DynamoDB database. So whenever anyone is trying to parallelly run it, it will not run. It will take only, it will lock the state file, it will run it, and then it will take the next one. So parallelly, it will not be running it. Got the point? So for that, let's go and write the code for it. So there is nothing to do. First, what we need to do in DynamoDB, what we need to create? We need to create a table. So you know how to create a table in DynamoDB? Yes or no? Do you remember? Forgot. Huh? Hey, don't see the book. देखो इधर देखो इधर देखो इधर how to create a table. Okay. Create table. So I'm using the same table name that I have written in the code. So you can give any table name is fine. Okay. What's the table name I'm giving here? DynamoDB Terraform state lock. So and the partition key is the lock ID. What's that? A column here we need to give what here? Lock ID. And then simply go ahead and then customize what we go for provision of here one of one create the table. Okay. So simply what we need to do. So once you create a table, main.tf, Terraform, backend S3, and backend you're putting this, right? And then key, and simply what you need to mention, DynamoDB underscore table. This one you need to, table name you need to mention. That's it. Automatically what it'll do, it'll uses this DynamoDB for locking your Terraform state file there. Let us take it. So first of all, what I need to do, I need to delete the state file or not, because I mismatched many times. Yes or no? I pulled it local, I changed it, I did a lot of things, right? So it is better to delete this because it will create again if required. But don't do this in real time. So deleting the state file is not at all a good option. Please remember. Okay, so if I take this code, it will give an error. Let's see. Let's see what is that error. No, Sumalika. Okay, see that code once. Hold on. Let me. See the code. You understand the code? Same code, but the thing is, DynamoDB got added. So you need to give the DynamoDB table name out there. So if I do Terraform plan, will this work? No, because I was using local state, right? Now again, I configured to remote. So for that, what I need to do? So did I destroy everything locally? Did I destroy it? Okay, I destroyed. There's nothing here. Correct, Dinesh. Okay, so what I need to do, what I was doing it, Terraform plan in it, right? Terraform in it. See, now it is successfully configured the backend to S3. Okay. Now if I do Terraform, apply, auto, approve. What will happen now? It will launch the EC2 instance, and this state file will get logged into the my DynamoDB table or not. So a record might have created there. So with this help of this locking system in DynamoDB, this will help you. This will help all the DevOps engineer. So not to corrupt your state file. So no two parallel writes will not be happening to the state file if you're using this lock system. So if you go and explore table items, and do you see this here? Yes or no? So it is creating the log system, and it is giving some hash something so that it maintains its own locking system inside it. Clear, Nana? Online, is this clear, please? Online, can I get CC till here? Destroy. Good. Lot of real-time things that we are learning here today. Okay, now I will show you one project. You tell me whether will you do that project or not. Okay. Okay. See, it's a mini project for you with actual real-time file structure. We already did this. We already did this. So what I want you to do is here. Can you create backend.tf? Backend.tf contains only our S3. Whatever the code that I have written, S3 backend code, that will be in separate backend.tf. So you have main.tf, which is actual code. Yes or no? In backend.tf, you have S3 state file and also DynamoDB state log. Nothing. Same code. This code will come. That's it in that file. Okay. And then output.tf. So many times we wrote the output.tf. And terraform.tf was, remember, terraform.tf are variables and variables.tf. Okay, see, I already wrote it, and tell me whether you understand this project. See here. This block is clear for you. Backend.tf. Louder. Online. Backend.tf is clear. Similar, what you're putting, you're just mentioning the backend as S3, and you're giving the S3 bucket, and then you are giving the DynamoDB table. Okay. Now TFRs, we have AMI, instance type, key name. Now variables.tf. In variables.tf, I'm passing what I'm creating a variables AMI, instance type, and key name. In output, you are outputting what? Public IP, instance ID, DNS, ERN. In main.tf, you are just creating one EC2 instance. We have done this already, but yes, key is prod here. You can give any name here. Dev, prod, whatever it is. You can write the provider here itself, or else you can write one more file called provider.tf. Or can you write provider information here also? That is the one I want to give you, the good one, Sumalika. So when you are doing this, if you get an error, there is no provider mentioned. So what you need to do? Provider TF you need to put. That is the main purpose that I am giving this. So we'll able to do this project. We have already done. The only difference is what in backend.if this line I have put it. That's it. Online clear? Online clear, please. Nice. And there is a code here called, I didn't put it here. Oh, the code is here. Oh, fine. So multi-region resource creation. What's that? In provider block, region we'll mention at only one. In provider block, what did we mention? Only one. So if you want to create it multi-region, we can mention that multi-region, for example. So vi main.tf. So I'm just giving the blueprint for you. Okay, see here. We have the provider. What is the region I have given here? Region. So here what you can do is you can write alias also. What is that? Alias. You can use alias. Alias also same thing. AP-south -1. So this is one provider and region. And then can I write one more provider here? You can write Azure provider also. You can write multiple providers, or you can use multiple regions also. AWS here. And then what you need to write here? Alias. Which one? Another region. Ireland. Huh? So EU-West-1. I remember because that is my Ireland. Huh? So region is equal to EU-West-. Okay. So now I have the two regions or not? So can I create one EC2 instance in one region, another EC2 instance in another region also? Possible. So how do I'll write one block? Tell me resource AWS underscore instance. So I call it as some example one or example. Tell me here. AMI blah blah blah. You will put it. Okay. Next instance underscore type blah blah. You put what's the T2 micro. Next here. Here we need to mention what here? Provider. Provider is equal to Very good. AWS dot alias you need to put. Alias meaning you no need to write alias here, but here you can directly pass the AP minus south minus 1. So like this, can I create one more block and call it as AWS dot EU hyphen west dot 1. Got it now? So if you want to pass, if you want to create multiple resources, then this is the thing. That's what I'm saying. Justice was, so this is just for your reference purpose. So, but in real time, it's better to have a separate for every region, right? But if you want, you can create a separate variables for it and get it. You can use Abhishek, no issues. Okay, so you will be doing that project. Please complete that project here. It's not a project, it's just a task for you. Okay, but I want to show you one project here now. That I'll show you the code, and that code you understood or not, you tell me, and you need to be doing that project. Will you? The one which I have given is a Chumma one. It's a task that you can do it in within few minutes. But the second one is the actual project. I'll be showing you that, and then tell me whether you understood or not. Don't worry about the code. Code is there already. Okay. So it is there in my GitHub. So the code is like this. I want you to create a VPC. We already did it. And I want you to launch 2 web servers with user data. Actual project? Yes or no? Getting it? So VPC need to be created. Inside the VPC, 2 EC2 instance should be launched. And that EC2 instance, whenever you're launching the EC2 instance, you need to pass what? User data also. So whenever you run the Terraform code, automatically 2 EC2 instances will be launched, and then your websites will be deployed automatically because you have the user data code there. You understand the picture? Online, do you understand the picture, Nana? So let me show you the code. Okay. Take your what else? So just a second. I wrote something different for you. This is a 3-tier project that I did it for you with them based on modules. So there is a new topic called what? Modules. What is that? So we use that modules and when we'll be doing it. Yeah. Anyways, see here. Okay. Don't worry about that modules. Okay. That is the project. I made it for you. And do you see this here project? Project VPC hyphen AC2. Okay. Go here. And then what are the things that we need for this project? One is main.tf, provider, user data, 2 user datas. You can use same only. You can use only one, but I want to show you 2 different things. Right? And then what you have? Variable. Okay, tell me technically which one you want to show first. Huh? Which one you want me to show? Provider, you know. What is there in the provider? So I just put it region and then this one here. And then, so let's go for the variables.tf. So as I told you that VPC is getting created. So in the variables.tf, so I'm just putting only the cider. And the main concept is coming here where in the main.tf. So in the main.tf, don't worry about this entire code. I just took this code from ChatGPT only, right? It looks really big, but the thing is, I showed you yesterday already. If you go and ask ChatGPT to provide the VPC code, it will give the VPC code. If you want to understand, yesterday I showed you how this VPC code will work. Do you see this here? Let me explain. What block is this? Resource block. So what is my resource type? AWS underscore VPC. What is my label here? Everyone you need to respond because cider block. This is the argument and var.cider. Where I am getting this? Variables.tf. Yes or no? In variable.tf, I have a CIDR. So I'm calling there var.CIDR. Okay. So this will create the VPC or not? This will create the VPC with the cider. Okay. Next, what I need to create? Subnets. How many subnets? 2 subnets I am creating. Subnet 1, subnet 2. Obviously, we have the resource block. Resource block, AWS subnet. Which one? What is the name here? Subnet 1. And this subnet 1 should be inside the VPC. How do you call? AWS underscore VPC dot my VPC dot ID. And then cider block, I need to provide the cider for my subnet 192.168.1.0/24. And then availability zone is this. And then map public IP on launch. That meaning whenever you launch EC2 instance inside this subnet, automatically public IP will be assigned. Clear this block. And another block is this. But this is in 1B 2.0. Next, what we need to create? Internet gateway. What we need to create? Resource AWS underscore internet gateway. What's the name, label name? This internet gateway need to be attached to the VPC or not? So VPC ID is equal to, how do you call VPC? AWS underscore VPC dot my VPC dot ID. Clear? Now what we need to create here? Routing tables. So called public routing table only. So give the rate and call it as here, label name as RT. But if you are really interested, give the name as public routing table. Okay. And then obviously this routing table should be inside the VPC. And inside the routing tables, we need to add the route or not. All traffic is routed to, in public routing table, all traffic is routed to internet gateway. Which one? So all traffic meaning I need to put the cider block, all traffic meaning 000/0. So gateway underscore ID. That meaning I need to call the internet gateway. How do I call internet gateway? AWS underscore internet underscore gateway dot IGW dot ID. Super. So here one more here, route table associations we need to do. Which route, in route table we need to do associate, right? Which subnet we need to associate? Public subnet. So subnet 1. So how do I call subnet 1? Subnet 1 I created here, right? How do I call subnet 1? AWS underscore subnet dot sub1 dot ID. Come here. Subnet ID. And this is the, so when you're creating association, what we need to have? Route table ID. Just now we created route table, right? AWS route table dot RT dot ID. Similarly, we are creating one more association, this one. And we are creating what here? What are we creating here? Security group. What are we creating here? What's the name of the security group? WebSG. Which one? WebSG. What's the name we are giving here? Web. And then obviously this should be inside the VPC. And then here we have something called ingress, egress. Say that. Ingress and then egress. Say that again. Ingress meaning inbound rules. Egress meaning outbound rules. So now in ingress, what are the protocols I need to allow? Tell me. One is HTTP, another one is SSH or not? Simple. So in ingress, I need to write two blocks. One is what? 80, which is enabled for all, and then ingress and port is 22 for all. And do I need to worry about the egress rule? All traffic is enabled or not? So all for -1 protocol is equal to -1, meaning here all traffic. Here it is what traffic? Only TCP, I mean only port 80, right? Here I'm mentioning what? All protocols. -1 meaning here all protocols. And what's the name I am giving? WebSC. And for that, for the backend, I need to create one S3 bucket or not? S3 bucket. Now, time comes. So how many web servers I'm creating here? Two web servers. AWS instance, and what is the label here? Web server 1. AMI instance, all these things. And this for this EC2, we need to attach the security group or not? We have already created a security group, get the ID. And then this EC2 instance should be inside the subnet or not? And get the subnet ID, sub1.id. And user data. Which one? User data. So you need to write this function here. Base 64 encode file. And we are calling which one here? User data dot sh. Encrypt here user data dot sh. We already have user dot sh here. Na? So user data dot sh. So the pure code is there or no? Our normal shell script code is there. You're calling that shell script. Okay. And similarly, I'm calling which one? For web server, I'm calling user data 1. You're calling through encryption file, your base 64 encode, Samalika. And then what it is creating? Load balancer. What is creating here? Guys, this is 3-tier project using Terraform. So it is creating a load balancer. Okay. Name is equal to what's the load balancer name? MyLB. Internal. Is it internal, external? Remember? Internal false. That meaning it is external. What is the load balancer type here? Application. Security groups. Can I call this a WebSG security group? And my load balancer should be inside the subnet, subnet2.id. And then I'm giving the name called web, and I need to create a target group or not? Guys, I'm creating a target group. So target group and target should be into this, and health check is what I'm giving here. Path is /. And we need to attach this target group to our load balancer or not? So here, our in the target group, while you're creating the target group, we need to register the EC2 instance or not? So you create a target group here, and then get the target ID. And then do you see web server dot ID? Web server 1, we are attaching to this target group, right? And then web server 2 also we are attaching to the target group. And we need to create one listener. Do you remember in load the way that you used to do manually? The same process I'm doing it here through Terraform. So here we have the listeners, and that's it. Output is the load balancer DNS name. You will get it. Guys, you understand the complete 3-tier architecture code. Sorry, this is not 3-tier yet. Let's get slowly, half and half. This code is clear. Everyone online? Online. Sir, 2 web application. Why? Oh, Dinesh, we need to have high availability or not? How many machines you need to have? Minimum 2 EC2 instances. If you're learning too much, this is a problem. First, what we did? We launched 2 EC2 instances. What is that? First, we created the VPC or not? We created a VPC and we created internet gateway. We created, but we haven't created in NAT because why? We don't have any private subnet, private routing tables. So as I don't have the private subnet, I don't worry about private route tables. I don't worry about the private subnet. I don't worry about the nothing. So everything I have put it into the public. So can you tell me what are the things I have created here? One VPC, 2 subnets, VPC after that, internet gateway, and I attach to the VPC. Next. Do you remember our normal steps? VPC. Create a VPC. Next, internet gateway. Next, we need to create subnet. How many subnets you created here? 2. Sub 1, sub 2 you created. Next, routing tables. And then while you create a routing table. And then we need to add the routes or not. All traffic is routed to internet gateway. Very good. And then we do the subnet association. So the 2 subnets should be associated to the routing table. We did that. After that, what we did? We created a EC resource block we created, right? That meaning 2 EC2 in the web server 1, web server 2. We created this instance. And then inside that we passed user data. And then after that, what we created? We created a target group, load balancer target group. And then we attached the target group. And when you are creating the target group, we have attached we have registered the EC2 instance or not? Web server 1, web server 2, we have registered to the target group. And then load balancer got created. Same thing, whatever we have learned in our AWS classes. If you remember my VPC topic and then load balancer topic in AWS classes, this will be super easy. Got it? Huh? Online, is this clear? So it created a VPC and then it created 2 EC2 instances. On top of it, we created what? Target group. And then we created a load balancer. And then while creating a target group, we attached it. And then this is the load balance. And then this output load balancer DNS name will get it. Yes, 2 SH same code. 2 files are there, same code only, but only different. What do you call? We remember in our AWS topic also, to show you the load balancer, I gave server 1, server 2. Remember? Like that I have given. Will you able to do this project? Will you able to do it by yourself? Here is my code. In the GitHub, see, please for this Terraform. Don't go through these 2 things. Your thing is only the last one. I would have created a separate repository for this, right? So don't go to the rest of the thing unnecessarily go mad, okay? Huh? Nothing to do. You need to understand the code, and then you just need to what? Don't just download and then Terraform apply, Terraform destroy. That is not what I'm expecting. Okay? Dinesh is already asking, sir, what we need to Terraform apply for that? So what I want to do is keep this code, but if you write this code with your hands one time, it's enough. What's it? Correct, right? If you write this code one time with your hands, all the logics that I have told you already before, we learned all the logic, right? How to call from one attributes, how to call the variables, how to call the labels, resource type. If it's the same topic, you use it here and you get it. So what I want you to do is to go here, pull this code, clone the code, and then first try to understand and then try to develop one by one. Write a resource code, write a subnet code, right? Write a resource, all these things, right? One by one. And what is the relation between all? Guys, if you don't know VPC topic, my AWS VPC topic, this will not this Terraform will not understand. You cannot understand. So if you